In this second video of the Nuro Blackboard series, we're going to go step by step from beginning to end on how your username, password and PIN code turns into an address and a private key, and finally how that is used to send a transaction. Okay, so step 1 is username, password and PIN. Why don't we have an example? So it's recommended to have a minimum of 8, so let's just say so that can be my username, and the password could be and the PIN okay, so we have the password and that. So what happens is we have these 3 strings and they are just basically added together, appended. So next part is in the coin utils browserify library, we have a function called create brain private key. Okay, so we call this function, it's all JavaScript by the way, so we call this function and we input this string to create the private key. The third part is that from the same library we have a function called create euro coin key, and there's also one which creates Bitcoin keys, and there's another one that creates Litecoin. So there are functions to create, and later on we're going to add, most likely we're going to add red coin and dark coin and all the other nice currencies out there. So this one takes a private key, and this is what we've made previously from here. So now we got the private key. Now we got the coin key, sorry. Now the coin key is actually a class from a library called cryptocoin.js.com, and it does a lot more than just the private key. It actually gives us the public address, the public key, and a few other nice things. But these are what we're interested in. So now notice this part, notice what we've done so far can be repeated on any device. So you can run your Nuro on one Android phone, use this username, password and PIN, and generate the same key, the same Euro coin key on any device. So if you then go to an iPhone or even just a web app, because we're going to have a web app, it's going to be a website as well, you can use the same credentials and get the same key. And notice that none of this actually involves any networking. So your password, your username, and your PIN are never sent across the network. So there's no way for anyone to intercept it and access your funds. Right, so it is much, much more secure than any standard centralized banking solution. Because your credentials are never sent anywhere. There's no, even the NSA can't intercept something that isn't actually sent across the network. So this part is why your account works on all devices simultaneously with no fuss. You don't need to back up any keys. You don't need to do anything. It just works. Now, step 4 is, so we've got the public address. So if we want to receive funds, we just put our public address here, and as you know in Nuro we have a send email and SMS button. So you could just press send email or send SMS on the receive tab, and basically Nuro fills out your public address for you, and it even leaves a line with a gap for you to put in the amount you want to receive, right? So you don't need to go typing this thing in yourself. There's also a QR code. Your funny barcode thing. QR code. So somebody else of Nuro can scan that code in front of you and do a person-to-person payment. And as you would have known, if you've tried Nuro, the payments are like instant. They take like literally a second. So when you scan someone's code and you pay them, they can see it straight away on their phone. It will take a few minutes for it to confirm, but if it's a small amount, you're not too worried, right? If it's a longer amount, you have a cup of coffee while you wait, but at least you know that they've already paid. Now, the 5th part is sending funds. So, to send funds, Nuro gets, the amount you want to send and who you want to send it to. And what it does after that is, it calls a function, and this again is in CoinUtil's browser file. It calls, actually no, that is not in CoinUtil's browser file, sorry. That is just in our Nuro.js actual code. And so what it does is it actually calls block cipher, and which has a function that builds a transaction. So it's actually something like new t. So the actual function is something like, there's a URL in front of it, but then there's like tx new, and you pass a JSON, which is basically like a structured array, and in there you pass the source address, which we have here, the destination, which you get from the person that you want to pay, right? So you will get them from the email they sent you, the SMS they sent you, or what you scan with the QR code. I don't recommend you go around typing it in. You probably end up trying it 60 times. And lastly, we need the amount. Okay, so once you send that, BlockCipher then returns us what's called a TX skeleton, which is basically an unsigned transaction. It's a skeleton because it needs some things to be filled out. So what it needs filled out is it's got some unsigned transactions in an array called toSign. And here, finally, we have a function in the CoinUtil's browser file library called signMessage. And this is used, so we call signMessage with the stuff to sign, and we get this signed transaction. So now it's properly signed. And again, this signing is all done on the phone, and the function is the same no matter which phone you're on, so it doesn't matter which device you're on, you don't need to be worried. As long as you got your username, password, and PIN, you can access your funds. And as long as the attacker doesn't have those three things, they can't access your funds. None of these sensitive information is ever sent across the web. Your private key is never sent across the web. BlockCipher doesn't know. They can't steal your funds. The NSA doesn't know. You've never sent the keys anywhere. It's completely safe. So as long as your username, password, and PIN are strong, and also your phone, the hardware itself is not compromised, which means you don't root it or jailbreak it. So finally, number 7 is we call BlockCipher again. And this time, there's a different function, which is something like broadcast. This is not exactly the right URL. You can look in the code. The code's on GitHub. It's open source. But basically, you broadcast it, and you send the transaction back with the signed transaction hashes. And remember, the way Bitcoin works is it's very easy to verify a signature, but only the person with the private key can sign. So we've got the private key here, which we use to sign the transaction, but BlockCipher can verify that transaction, and when once they verify, they broadcast the network, and the whole Euro network then verifies that through mining, or later on potentially minting, and then that will eventually end on a block, and that becomes a confirmed transaction, and everything's full circle. So I hope that gives people a better idea of the security behind Nuro, and hopefully that puts to rest all these security concerns regarding where the keys are stored, whether it can be hacked, and all those kind of things. Thanks.